It started with a faint irregularity hidden inside a collection of raw telescope data, something so subtle that almost everyone overlooked it. Buried within the observations was a sequence unlike anything astronomers expected to find. The pattern was unusually precise, repeating with remarkable consistency instead of behaving like the chaotic signals normally produced by natural cosmic events. It did not resemble the signature of a distant star, a cloud of dust, or the debris from a passing comet. The more closely researchers examined it, the less it fit any known explanation. The source of the mystery was the interstellar object known as 3I Atlas. Ever since its discovery, the object had attracted worldwide attention because of its unusual properties. Scientists agreed that it originated from outside our solar system, but many aspects of its behavior remained difficult to explain using familiar models. As speculation grew, rumors spread online that additional observations made by the James Webb Space Telescope contained unexpected details that had never been publicly discussed. Although those rumors remain unverified, they fueled countless theories about the object's true nature. When 3I Atlas was first detected, researchers naturally compared it with previous interstellar visitors such as 1I Oumuamua and 2I Borisov. Those objects provided valuable opportunities to study material that formed around distant stars before passing briefly through our solar system. At first glance, 3I Atlas appeared to belong to the same rare category. However, continued observations suggested that it behaved differently in several important ways. Most comets develop a bright cloud of gas and dust known as a coma as they approach the Sun. Solar heat causes frozen materials inside the nucleus to vaporize, producing visible tails and releasing a mixture of gases that astronomers can analyze. Observations of 3I Atlas, however, raised questions because some expected features appeared weaker or different than anticipated. Instead of fitting neatly into the profile of a typical comet, the object encouraged scientists to investigate whether its composition or history might be unusual. Using powerful infrared instruments, astronomers carefully examined the light reflected and emitted by the object. Spectroscopy allows researchers to identify molecules by measuring how they absorb and emit specific wavelengths of light. Every new observation added another piece to the puzzle, but the complete picture remained incomplete. The available data suggested that 3I Atlas might contain materials unlike those commonly observed in comets within our own solar system, though scientists emphasized that additional observations would be necessary before reaching firm conclusions. The uncertainty surrounding its composition quickly became one of the most discussed aspects of the discovery. Researchers proposed several possibilities. Perhaps the object formed in an environment with a very different chemical makeup from our own planetary neighborhood. It could also have experienced an entirely different evolutionary history while traveling through interstellar space for millions or even billions of years. Every possibility opened new scientific questions rather than providing simple answers. As interest intensified, one rumor spread especially quickly across social media. According to online claims, the James Webb Space Telescope had been directed to perform detailed observations of 3I Atlas, producing data that was never officially released. These stories described mysterious infrared signatures, perfectly symmetrical structures, and unexplained light sources hidden within the object's spectrum. Despite their popularity, no verified evidence has confirmed the existence of such leaked observations, and space agencies have not announced any discoveries supporting those extraordinary claims. Even so, the rumors inspired widespread debate because the James Webb Space Telescope possesses capabilities unlike any previous space observatory. Its highly sensitive infrared instruments can detect faint heat signatures, analyze the atmospheres of distant worlds, and reveal details hidden from optical telescopes. If Webb were to observe an unusual interstellar object in detail, the resulting data would undoubtedly become one of the most valuable scientific datasets ever collected. Some speculative interpretations went even further, suggesting that subtle variations in the object's infrared emissions appeared surprisingly regular rather than completely random. Supporters of these theories argued that the repeating signals resembled organized patterns instead of naturally fluctuating thermal radiation. Others strongly disagreed, pointing out that random noise, instrument effects, or incomplete datasets can easily produce misleading patterns that disappear after more thorough analysis. Another characteristic that attracted attention was the object's enormous estimated size. If future measurements confirm that it is significantly larger than previously observed interstellar visitors, it would immediately become one of the most remarkable objects ever detected entering our solar system from another star. Such a discovery would challenge existing statistical models and encourage astronomers to reconsider how frequently large interstellar bodies travel between stellar systems. Its path through the solar system also became a topic of discussion. Scientists routinely calculate the trajectories of incoming objects with extraordinary precision, allowing them to reconstruct where they originated and predict where they will travel next. In the case of 3I, Atlas, researchers carefully analyzed its motion to better understand its birthplace and the gravitational influences acting upon it. While some internet discussions portrayed its trajectory as impossibly precise, astronomers generally explain such motions through well-understood gravitational physics unless compelling evidence suggests otherwise. The object's arrival naturally revived memories of the debate surrounding Oumuamua, whose unusual acceleration generated years of scientific discussion. Some researchers proposed entirely natural explanations involving unusual shapes or material properties, while others explored more speculative possibilities. Those debates demonstrated how extraordinary discoveries often inspire both careful scientific investigation and imaginative public speculation. As new observations continued, 3I, ATLAS became more than just another astronomical object. It represented a rare opportunity to study material that had spent unimaginable lengths of time traveling through the space between stars. Whether it ultimately proves to be an unusual comet, a previously unknown class of interstellar body, or simply an object that challenges existing models, its journey offers scientists a chance to expand our understanding of how planetary systems form and evolve throughout the galaxy.